All right, today we are diving into a story that is so much more than just a scientific paper. It's a story about hope, about persistence, and about how science can completely change the world for people. We're talking about cystic fibrosis and the incredible breakthrough that rewrote the future.
And it all starts here with this really powerful memory from Dr. Michael Welsh, who's a key figure in this story. This quote, it just hits you, right? It sets the stage for what cystic fibrosis used to be. I mean, imagine being a doctor, looking at a young patient, and knowing that was their likely future. That's the weight that fueled decades of work.
So, yeah, that heartbreaking reality, that was the starting point. But this is not a story about despair. Not at all. It's about how brilliant, dedicated people took that reality and just dismantled it, piece by piece. We're going to walk through exactly how science made that happen.
So first, to really get why this breakthrough was so huge, you have to understand just how tough this disease was. Let's take a look at what life was really like for a CF patient before all of this.
Think about this for a second. This wasn't just getting sick once in a while. It was a constant, grinding, daily battle. That little girl Dr. Welsh remembered, she would have spent hours every single day on therapies that involved literally pounding on her chest just to clear out enough of this thick, sticky mucus to be able to breathe. It was a full-time, painful, exhausting job.
So, how do you even begin to fight a monster like that? Well, what's so fascinating is that this whole revolution didn't start with a big, grand plan to find a cure.
And that's what's so amazing. The starting point wasn't let's cure CF. It was a much more basic fundamental question. Dr. Welsh was just driven by pure curiosity. He wanted to understand how salt, chloride ions, moves in and out of the cells in our lungs. And this is a perfect example of why that kind of basic what-if science is so important.
And right here, this is the moment everything changed. See, while Dr. Welsh was in the lab studying this basic process, he was also in the clinic treating kids with CF. He saw their struggle up close. This quote is where those two worlds collided. His scientific curiosity suddenly had an urgent human mission.
Okay, now things really start to pick up speed. Because understanding the symptoms is one thing, right? But finding the exact root cause down at the genetic level, that was the key that was about to unlock everything.
All right, so meet the star of our show, the CFTR protein. The easiest way to think about it is like a tiny, tiny gate on the surface of your cells. Its whole job is to open and close to let chloride ions, which are part of salt, move through. Seems simple, but it is absolutely essential for keeping the mucus in our lungs and airways thin and watery, the way it's supposed to be. So how did they connect the dots? It was really like this amazing piece of scientific detective work. Step 1, a bunch of research teams found the specific gene that's mutated in people with CF. Step 2, Dr. Welsh's lab figured out what the protein made by that gene actually does. It's the chloride gate we were just talking about. And boom, step 3, that explained the entire disease. A broken gene leads to a broken protein gate. The chloride gets trapped, water balance is thrown off, and the mucus gets thick and sticky. Mystery solved.
But here's where it gets complicated. Broken can mean a lot of different things. In fact, there are over 1,000 different ways this protein can fail. For some people, the protein just isn't made at all. For others, it gets made, but it's all misfolded and gets stuck inside the cell. And for some, it gets to the right spot, but the gate is just jammed shut.
So with all these different problems, scientists had to be smart. They focused on the biggest target first. The most common mutation by far is called delta F508, and what it does is cause the protein to misfold. Think of a piece of origami that's just crumpled up. The cell has this quality control system that sees this messed up protein, tags it as garbage, and destroys it before it ever even has a chance to get to the surface and do its job. Cracking this one was the key to everything.
So the protein is misfolded and gets thrown in the trash. Game over, right? Not even close. This next part, this is the aha moment of the entire story. This is where they proved that this supposedly broken protein wasn't a lost cause after all.
And the breakthrough they had in the lab was just so elegant and simple. So remember, the problem was that this delta F508 protein misfolds at normal body temperature. Well, in the lab, the team tried something kind of wild. They just lowered the temperature of the cells. And you're not going to believe it, but that simple change was enough. It helped the protein fold correctly, make its way to the cell surface, and actually start working.
This quote right here, it just captures the electricity of that moment. I mean, obviously, you can't just lower a person's body temperature. That's not a real treatment. But this experiment was a massive proof of concept. It screamed that the protein could be fixed. It wasn't a hopeless case. And that opened the door to a brand new, thrilling question. Could we create a drug that does the same thing?
And that question led directly to a whole new class of drugs called CFTR modulators. And now, we get to the best part of the story, the payoff. Let's look at what this all meant for the actual people at the heart of this. Just look at this number, 90%. After all those decades of research that started with a simple question about salt, a therapy was developed that helps the vast majority of people with cystic fibrosis. This wasn't just a small improvement. This was a revolution.
And you can feel how real it was in this quote. This wasn't some subtle change that you had to squint to see over months. This is from one of the very first patients in a clinical trial. He knew, instantly. All that complex science translated directly into a feeling, into health, into a life being handed back in real time. And the stories, wow, they're just incredible. Listen to this one. A college student who is literally having conversations about needing a lung transplant starts this new therapy. 2 weeks later, he goes for a 2-mile run. A run! But even bigger than that, he started planning for a future, a career, dating, a family, things he never, ever dared to imagine for himself.
And that's the bottom line. The breakthrough wasn't just about making it easier to breathe, it was about giving an entire community of people their futures back. It completely changed what it means to live a life with cystic fibrosis.
An incredible success story like this doesn't just happen by accident. It actually leaves behind a blueprint, a kind of playbook for how we can make these kinds of breakthroughs happen for other diseases. Let's break down what those essential ingredients are.
Dr. Welsh boils it down to these 3 pillars. You need strong universities, places where that curiosity-driven basic science is allowed to thrive. 2, you need reliable funding from places like the National Institutes of Health because these big ideas take time, and you can't be afraid to fund things that don't have a guaranteed payoff. And finally, you need partners in industry who have the resources and expertise to turn that basic knowledge into an actual life-saving medicine.
And that brings us right up to today. This quote really says it all. The progress has been, as Dr. Welsh put it, unfathomable. But the work isn't over. Like in any great scientific story, as soon as you cross one finish line, you can see the next starting line up ahead.
Which brings us to our final question for the future. For that last 10% of patients whose mutations don't respond to these drugs, gene therapy is the next great hope. But here's the catch. Our lungs are absolute masters of self-defense. They are designed to keep foreign things, like viruses, out. The problem is we often use harmless viruses to deliver genetic cures. So the big question now is, how do we outsmart our own body's amazing defenses to get these next-generation cures where they need to go? It's the next great puzzle in the incredible and still unfolding story of cystic fibrosis.